Hello, Ishan. Am I audible? Okay. Let us wait for 2 minutes. Otherwise, I'll be taking one problem on sections of solids. So it is an interesting problem. We'll see. Okay, I think we can start. So, welcome to live lecture 8 of the course Engineering Drawing and Computer Graphics. So this course is being actually conducted by Professor Rajaram Lakkaraju, and today myself Sanika I'll be conducting this live lecture for this course. So today, like I said, we are going to solve one problem on sections of solids, which also involves auxiliary planes. And this problem will also cover the questions that have been set in the last assignment. So I think this problem will cover many things. So the problem is a cone of base diameter 70 mm and axis length of 80 mm is kept on the horizontal plane on its base. So front view, in front view it will look like this. This height is 80 and this will be 70 mm diameter, which will be represented as phi. Now they have said that it is cut by auxiliary plane in such a way that the true shape of the section is an ellipse. So we can cut this cone. You can imagine that you are cutting the carrot or carrot in the salad. So if you cut it exactly parallel, it will be a circle. If you cut it such that the angle between the this perpendicular axis and the plane of cutting is such that it is between 90 but less than this particular angle which the cone makes with the horizontal. So in this case it will be a ellipse. So if you start out if you start out with a plane which is horizontal, initially it will cut a circle. As you rotate this plane, it will start cutting a ellipse until it reaches a plane which is parallel to the generator of the cone, either this or this. At this point, exactly at this point, it will trace a parabola. So you have already learned this in the conic sections, I think in week 1 or week 2. And if you further rotate this beyond this angle, then if it is a plane like this, it will be a hyperbola. And finally, instead of a horizontal plane, if the cutting plane is vertical, we will see a triangle like this. So what they have said is the plane is such that it is tracing a ellipse. So any plane which makes a angle which is between horizontal and this, it will trace a ellipse in the cone. So now, if I have a plane like this, I'll draw a plane, similar plane. Wait, I'll better draw it with a line. So, so if I have a plane like this, so the angle made by this plane, the orange line, it is less than the angle made by the side of the cone here. So it's going to trace a ellipse. So if I move this plane here, it will trace a ellipse. It will trace a ellipse here, which in top view will look something like this, and where the top view of the original cone will be something like this, circular, and in between that we have a ellipse, which will correspond to these uh, projections. So, so the next condition is that the plane is such that the major axis is the maximum possible axis. So if you are moving this plane in this view, in the front view, what you see is the major axis of the ellipse. So if you are cutting it like this, in top view, in not top view, in auxiliary plane here, you will see a exact ellipse whose major axis will be this and minor axis will be like this, which will be always at the midpoint of the intersection of this, somewhere here. If you move this line slightly, if you have a another plane parallel to this plane here, then your ellipse will have one of the axis here and the minor axis here, from this midpoint. So if you have a ellipse on this plane, what you see, the minor axis, you see it as a point. The whole line, you see it as a point. So that means that the minor axis is perpendicular to the vertical plane and parallel to the horizontal plane. So in top view of this thing, if you have a circle like this, if you have a circle, so the top view of this cone will look as a circle, and this point, this vertex over here will be the center of the circle O. So if you have this circle, the ellipse, if I drop the projections from the endpoints of the intersection here and here. So when you want to trace the points from a cone to the circle, what you need to do is you need to have, so if I name this as A and this as B, so OA, you see this OA line as this line. So all these are imaginary lines that we are trying to construct in order to mark the points on this surface of the cone. This is OB line. This line OB will look like this line in the top view. So here this point is on line OA, so it is on line OA, and the location is this. So this will be one end point of the ellipse. Let us name it as 1, and this point is on line OB, and the location is this. So I drop a projection from here, and line OB is this line. So this point will be seen here in top view. So if you try to draw a ellipse here, So if you try to draw ellipse here, it will be something like this. So the major axis is this length. This is not the true major axis that we see here. This is auxiliary major axis. But what I'm trying to say is this length will be the major axis of the ellipse, uh, which the plane is sectioning the cone into. So as I move this line parallel, I am not changing the angle with respect to the perpendicular axis, but if I move this line, I'll get maximum major axis when my plane is passing through this point A. When my plane is passing through this point A. So this is the maximum major axis that I can get, because below this, below this, I won't get a length bigger than AD. I will always get a smaller length. Or if I go here also, I'll get a smaller length. So AD is the maximum length for a given constant angle. If I change the angle also, if I change the angle also, here it is some length where this line intersects here and here. If I come down, it will intersect here and here. If I further move this line down, it will intersect point A and some point D1. So the point is that if you want that the major axis is maximum, the plane should be passing through point A. Second condition is that it should be a ellipse. So the angle with the perpendicular should be in between this angle. So this is the minimum where it will be circle. This will be a parabola. In between this, it will be a ellipse. So if I have a line here like this, by parallel line concept, this is also parallel. So line here. So this angle and this angle are same. So if I have a plane which passes through A and makes any angle here, which is in between angle OAB, it will always trace a ellipse. Okay, so we made two conclusions here. One, so here we actually have to find a plane that is sectioning the cone such that the minor axis is 40 mm and major axis is maximum possible. So for the major axis to be maximum possible, we have said that the plane that sections this cone should pass through this point A, and the angle made by the plane can be not zero, little more than zero, somewhere here, and maximum angle can be here like this, after which it will make a parabola. So um, so one conclusion, the plane must pass through A. Now the next condition is that the minor axis should be 40 mm. So now what happens is if you have a cone like this and you have a plane like this. So what I'm saying is this plane can make any angle little more than 0 and little less than the angle made by edge AB. So as you move up and up, if your plane is horizontal completely, you see a circle. As you rotate like this, it starts becoming a ellipse. So in top view, if the plane is horizontal, the section plane is horizontal, the section will be exactly a circle. If I move slightly like this cone is like this. So if I have it here, my end of the ellipse is reducing. So the uh, instead of this circle or this circle, I'll have a reduced circle, as well as my cone is going inside from all sides, so even this axis will get reduced. So the ellipse gets goes on shrinking as I move the uh, sectioning plane. So if I go to another line here, my major axis will shrink further and even the minor axis will shrink further. So it will keep on becoming smaller and smaller. So if uh, uh, shape- so if this was my initial circle here, if this was my initial circle, then as I rotate the plane, this is going to shrink as well as this will shrink. So in the first plane, in this plane 1, the section will look like this. This is my base of the cone. This is the base of the cone and the section will look like this. If I further rotate the plane to position 2, then this will get reduced even further. So it will come somewhere, it will come somewhere, it will be here. So if I have the plane in position 2, if I have the plane in position 2, I will see even smaller ellipse in the top section. And my condition is that the plane is passing through this point B. That's why all the ellipses are getting coming here. So this is the base. For plane 1, this will be the section. For plane 2, only this will be the section. So uh, now if you see this one, I'll copy this ellipse over here. If you see the plane 2, so let us draw a plane here like this. Now let it intersect line AC at point D. Okay, so this is the center of my circle, which is A. This is point B and this is C. So how do I trace this point D? So D is on AC. So this is my line AC and I will drop a perpendicular from here to AC. So if I do that, I can locate my point D in the, so this is my point D in the top view. So my ellipse, this ellipse should have an endpoint here. And now how do I trace the other points? So for that I need the other generators of this cone. So I will draw some generators of this cone. So what you usually do is you divide the circle in equal parts and then you uh, project those points uh, in the top view. So I'm drawing these lines here. I'll name them as 1, 2, 3, 4. So this is like this. Okay, so that's it. So we have some points on the circle. So like this point A and B were representing this line. Now I have points 1, 2, 3. This is C, 4, 5, 6, and B. So if I project line from point 2 here, this is line, this is the top view of line A2. So which will be visible here? A2. If I project it here, this will be my projection of point 2. Point 2 over here, projection of point 2 as well as point 5. Similarly, I can project point 1 and 6, 3 and 4. So can you imagine, this is the cone. I'm drawing lines on the surface, and in top view I can see them like the spokes of the wheel, whereas if I see the same lines on the surface of the cone in front view, I will see them as simple triangles. So let us trace point 1 and 6 also. So that becomes 1 and 6, and this will be 3 and 4. So this is 0.16, this is 0.34, and the corresponding lines from the center will be like this. So you can start from here and join here. This will be line A1, or the hidden line will be behind the same line A6, or you can have line A3 or A4, and I'll have a line A2 or A5 here. So now when I'm like this, when I have a plane like this which is intersecting that cone somewhere, in the side view I see a straight line. But in top view it is not intersecting in middle, like the edges will be along the surface here, like the surface of the cone. So if I want to trace this point, so in this plane I see all points in a line. Whichever point I have, I see it as a point. If I in the ellipse, in this ellipse, in ellipse like this, if I draw a line like this, I see it as a point here. This line could be a point here, or this point, this end is this point. This point is point B. So, but in top view, it's not a line. So this is basically intersecting somewhere on the surface of the cone. So I cannot directly project it down. I need to know till where I need to project it. So this point I know. So now this particular point, let us name it as E E1. So this point lies on line A1 or A6, and its location is this. So if I drop a perpendicular from this point here, then the location of point E1 will be the intersection of the line in top view. So this is line O, one I'm sorry, A1 or A6. This line is A1 or A6. So point E1 can be either on line A1 or line A6. This is the projection. So this will be my point on the ellipse. So this was the ellipse that I had randomly drawn. Luckily now the point has come here, so you can join this point. Similarly, if this is the point, you can trace it over here. If this is the point, it's directly on line AC, which is already horizontal. So on line AC, you have marked point D. So this becomes your ellipse in top view. And if this is your major axis, then your minor axis will be in the at the midpoint. So this will be your minor axis. This is your minor axis which passes through the midpoint of your major axis. So here also your minor axis will be a point which is midpoint of point BD. Okay, so now the next condition is that the minor axis of the ellipse is 40 mm. So now if you are looking at the ellipse here, all these lines, if you are looking at the ellipse here, these lines, these lines are seen as a point in front view. This line is seen here as a point, this line is seen here as a point, and this line is being visible somewhere maybe here on as a point. So what does that mean? If a line is seen as a point in front view, that line is perpendicular to the vertical plane and parallel to the horizontal plane. So it is like this. If this is the vertical plane and this is the horizontal plane, the line is like this. So I see point here and the true length in HP. So this minor axis is 40 mm. The true length I'm able to see in the top view here. So, but we'll go to the next figure to see how this minor axis will look. So if this is the center, this is the center of my cone in top view. This is A point. So now I just know that in the previous slide, this was a random construction. We still don't know what is the length of the minor axis. It could be anything. I just proved a point there that your minor axis will be passing through the midpoint of your major axis, which will be visible here, and which this will be the midpoint in front view. This will be the midpoint in top view. Now let us come to the condition that is given in the problem. So they have said that it is 40 mm. I just told you that since the ellipse is seen as a line here, all the lines on this plane of the ellipse are parallel to HP and perpendicular to VP. So since it is parallel to HP, we can see the true length in the top view. So this minor axis could be any line, could be any line whose length is 40 mm and is symmetric about this axis. Uh, and is symmetric about this axis which passes through A. Okay, so the minor axis could be anywhere. It could be here, it could be somewhere here, it could be somewhere here. I don't know. But what I know is that the true length of minor axis is 40 mm. So if if this was our ellipse, if this was our ellipse, then I'll maybe name this as 1, or I'll name them as small letters A, B, C, and D. So AC is my minor axis and BD is the major axis. So this AC could be anywhere, but I know that the endpoints A and C will lie 20 mm above this center line and 20 mm below this center line. So I get the locus of the points A and C, which will be what? Parallel lines. Okay, so I'll draw a parallel line here. So this line is this line is 20 mm above the point A center, and I'll draw another line which will be the locus of point C. So this is locus of point A, this point A, and this is the locus of point C. So now let us assume that okay, so I need to draw all these lines again. I'll just copy paste them from here. So yeah, so I'll have a similar line here. Okay. Huh. Okay, so yeah, where were we? So I was saying that I'll take a minor axis which is 20 mm. Let it be some axis that I've just placed here. Some axis like this. So if this is some line which is 20 mm, let us just try to see how it will look here in the front view. So how do I trace this point to the front view? I I can drop a perpendicular from here. I'll drop a perpendicular from here. Where do I intersect it? Now it should intersect this line A. So this was our point 1, this was 2, this was 3, this was B, this was C, 4, 5 and 6. So this point, which we have considered the minor axis right now, this point will lie on line A1. So point 1 is projection of point 1 is this. So my line A1 is my line A1 is this point, this line. And now I have a point here, this point A here, which lies on line A1. So this lies on line A1 and projection is this one. So this is one of my points of the ellipse. So if I get one point of the ellipse, either this or this, so if this is the ellipse, I have marked some point here. So I know that I have fixed that the one end of the ellipse is starting from point B. So if I draw in front view, my ellipse is going to look like a straight line which passes through this point that I just marked. So if I draw a line through B through this point, it will intersect the cone on the other end. Let us say at point uh, D, like we took before. So now what I assumed was that this is the location of my minor axis. Okay. And if I transfer these points here in the front view, I see that the minor axis will look as a point at this place. But like I told you before, if this is the ellipse, then its minor axis is measured where? At the center of the major axis. So we see see one axis in the front view, which is BD, and we see one axis in the top view, which is AC. Not this A. I'll name this as actually BD and MN. Okay, so this is M and this is N. So let us assume that my minor axis is MN. This is BD. So BD is the true length of my major axis, and this mn is the true length of my minor axis. So in front view I see the true length of my major axis. Where should be the midpoint? Midpoint should be around here, and only if the minor axis passes through this midpoint, only then it will be called as a minor axis. Otherwise, here actually, if I mark this point D on the in the top view, if I transfer this point D in the top view, so D is on AC, so I'm extending this projection till line AC. This line, I'm extending this to till this line AC. So this is my point D. All right. So how will my ellipse actually look? Uh, so if I get this ellipse here, then the end point of the ellipse is here, and I know that this is my this point. This point lies on the ellipse. On the ellipse, so I will reduce this ellipse such that this point lies on the ellipse. Okay. So uh, uh, yeah. So this is my ellipse. Okay. That will be traced if I am assuming that this point is on ellipse and this distance is 20 mm. Okay, so this will be my ellipse. But if you see, this is not the midpoint. This is away from the midpoint of the major axis, which was BD. And this I had assumed that if this is the minor axis, but this is not the minor axis. So you cannot randomly choose some point in top view and call it as minor axis, because any line like this, it is not going to be a minor axis of the ellipse. It will be a line, the points will lie on the ellipse, but it could be a line here, it could be a line here, it could be here, here, or here. So so that's why you need another locus of the um, points M and N. So this is my minor axis MN and this was my major axis BD. So in top view, what do I know? Point M lies on this line and point N lies on this line. Okay, so uh, I will, yeah. So point M on this line and point N on this line. Now in front view, I'm saying that the locus of this minor axis will be what? Midpoint of BD. So if I have any line which is basically the trace of the uh, section plane. If I have any plane which is cutting like this, I see it as a line in front view. So my this line MN will be seen as a point which is midpoint of this BD1. If I have another line here, again the MN, the minor axis, will be midpoint of this line BD2. So now if you look at similar triangles like this, and uh, here I'm drawing a midpoint, here I'm drawing a midpoint, here I'm having a midpoint. If I join this line is going to be parallel to line AC. So now I have another locus of the so now I have another locus for all the points that are on the minor axis. So this is M comma N. This is also M comma N. This midpoint will also correspond to the 2 points of the minor axis. Okay. So finally, if we see, I can draw the locus of the midpoints as a line. Did you get it? This we use the similar triangle concept here. We use the similar triangle concept. So if you have a line parallel to AC, which passes through the midpoint of AB or midpoint of BC, any line I draw here like this in this triangle, that line will also get bisected by this line. So I'll name this as EF. Alright. So now if I have a ellipse like this, midpoint is this. If I have a ellipse like this, midpoint is this. So I've got a second locus for the points M and N. Once it might, so M and N will lie on this line EF. M and N on line EF. This is in front view. In top view, I got a locus that M and N lie on these parallel lines. So now, uh, when I started the class, I told that if this is the cone, I'll go back to that figure, or did I keep it? Yeah. So here I showed that if the section plane is horizontal, the section is a circle. Let us keep this line here. If it is horizontal, it will cut a circle. If I rotate this line like this slightly, it will cut a ellipse. If I further rotate this section plane, it will still cut a ellipse until this line is parallel to the generators of this cone. That is, it is parallel to this line AB. So this line AB is the actual angle made by the generator with respect to the horizontal plane. So similarly, is AC also a generator of cone? Correct? So when I have a line like this, imagine it as a plane which is parallel here, which is perpendicular to plane VP and parallel to this line AC. Okay, so now uh, this line is going to trace what? It will cut a parabola. So this line EF will see as a parabola in the top view. So in in top view, I had locus of Mn, that locus of Mn is line EF. In front view, locus of M and N is line EF. In top view, in this view, locus of M and N are the two parallel lines. Okay, so but I need both the locus in one view. So how do I get it in one view? That's why I'm saying that imagine this line EF, that it is the trace of a plane which is perpendicular to the vertical plane. So that's why we are able to see it as a line, and it is parallel to line AC. So this plane, if such a plane is intersecting a cone, it is going to trace a parabola in the top view. So, and where are my points M and N? M and N are also on the surface of the cone. And this line EF is also going to trace a parabola on the surface itself. So I will remove this ellipse. We are not, because we are not sure this is the ellipse that we want. Okay. So uh, if I want to trace the parabola which corresponds to this line EF, again I'll put a perpendicular from point E. Now where will point E intersect? Point E is on line AB in front view. So in top view, where is line AB? This is my point A. This is my point B. So point E will be on this line, and this is the perpendicular coming from here. So this is my point E. Similarly, if I have a few more uh, generators of the triangle here, like this, few more generators I'm drawing so that I get more and more points. Okay, so now this line EF, I'll make it a little darker so that it is visible. It's stand. Huh. Okay, so I'm trying to uh, mark the points on this EF plane. I'm sorry, EF plane in the top view. So E is here, and my is point F lies on line AF. So I'm sorry. This is actually point on the base of the this circle. So this line is equal to this line. So F lies somewhere on this line, and I know that it is on the base. So it is at the edge of the circle. Correct. So this is my point F. This was my point E. Now I can have, since I drew some more generators, this was one of the generator I drew. I'll name it as A S. So this AS, how will it look in top view? So I will have to first draw the projection of the line AS in top view. How will I do that? I know that point S is on the circumference. I know that point S is on the circumference. So I'll drop a perpendicular from point S, this one, and uh, where will I intersect it? I will intersect it either here or all the way down on this side of the circumference. So let us assume for now that this is the point of intersection. So the projection of line AS will look like this in the top view. So this was the line that we projected right now, whose projection looks like this. Alright, so this is my point. This is my point S. Now what do I have? I have this point which is in the plane of this EF. So to mark that point, I'll draw another perpendicular from that point, which should intersect the line AS. So wherever it intersects the line AS, let's call this point as uh, what should we call it? Let's call it E1. So this point will be my point E1. Okay. So then finally what I get is I will draw it with a red pen. So if you do this, if you get enough points, so this point you can get it on this side also. So this is the starting point. This is the apex of my parabola. So parabola will look something like this. This will be my point E. This will correspond to the point F, and I have marked some point S in between. So I'll get a parabola like this over here, like this. Alright, so now what did I have? EF was the locus. EF was locus of the points M and N, the end points of the minor axis. EF was the locus. So in in front view. Now, if that is the locus in front view, how is it looking in top view? It is looking like this parabola. Now, in top view, I have another locus of point M and N, which is 20 mm above the center A and 20 mm below the center A. So wherever this parabola and these two lines will intersect, that will give me my actual point N, and it intersects it here. That will be my point M. So then I can go ahead and uh, I will just take a new line. Then I can go ahead and color outline. Let us take it as some very different color. Let us take it as dark yellow. I'll make it really thick. So this point M, this minor axis Mn will be here. So M is intersection of this locus and the parabola. N is the locus, is the intersection of this locus and the parabola. So now I get the points M and N, and I already know that it passes through point B. Since this is the locus of the midpoint, if my Mn is on this line or on this parabola, it means that if I draw a line passing through B, through this point and it reaches this point, this particular point, wherever this plane intersects EF, it will be the midpoint. So Mn will always be on the midpoint and I'll get some ellipse which corresponds to, if I draw a perpendicular from this line, from the red line. If I draw a perpendicular from the red line here, where will this intersect? It will, this point D, this point D is on line AC. This is my line AC. So wherever this projection will intersect, that will be the point D of my ellipse, and this will be the minor axis. So I'll get it like this. I'll get the ellipse like this. Now what I did, I transferred the locus from front view to the top view. Similarly, similarly, I'll take everything off from here. Uh, Similarly, if I want to take the locus from top view to front view, okay, so I know that. So right now what we did, we took the locus which is the midpoint line EF and we tried to trace it in the front view. Okay. Uh, so which we already know that will be a parabola in top view. Now instead of that, if I try to trace the lines M and N, which are the locus of uh, M and N in front view here. So here what is happening? If you see in top view, you can imagine this line as a plane which is parallel to the vertical plane and perpendicular to the horizontal plane. So in again we'll go back to the first slide here. So if a plane which is sectioning the cone is perpendicular like this here, it uh, is perpendicular here, it will cut a hyperbola. And if it is passing through the apex, then it will be a triangle. But otherwise, any plane here like this, or if I move it here or here, anywhere, it will trace a hyperbola. So now, how are we looking? This is the cone and this is the plane. Now, rotate it. This was my cone and this is the plane. So in top view, I will see again a line. Right now, this plane will be seen as a line here, right? This plane which is perpendicular to HP, parallel to the axis of the cone, this plane will look like this here and it will trace a parabola. Now what I'm saying, rotate it like this, rotate it like this. So what will I see? this plane will be this plane will be visible like this, somewhere like this, and we'll see a hyperbola wherever it intersects the cone. So here, this line MN, I can transfer it to the front view. So if this is the point M, this is the point M. I'm sorry, this is point, let's say M1, which is on the circumference. So I'll need to draw a new this thing generator of the cone, which joins the center and point M1. So this AM1 is in top view. How will it look in the front view? What will I have to do? I'll have to project the point M1. Ah, I'll have to project a point M1. Which color should we keep this one? No, this is not visible. Blue, green. Let us keep it as red. So this point M1 is on circumference, so it should intersect the line BC in front view. So wherever it intersects, that will be my point M1. So the generator will look like, so the generator will look like this in the front view. Now this is my M1 in front view. Now this same line intersects. So I had already named these points as 1, 2 and 3, right? So this line M intersects the A3 line at this point. Okay. So if I draw uh, a perpendicular projection from this point, it lies on A3. So this is my line A3 because my point 3 will be this. Similarly, so I will make this also red. Okay, so this is my line A3, and uh, my A3 will be here. If I draw a perpendicular from point 3 and let it intersect somewhere on BC, so that will be my point 3. Am I right? This will be my point 3, and wherever this projected line intersects this line A3 will be my point. I will call it as M3. Okay. So similarly, again now this line will intersect somewhere here. You can trace it over here. So similarly this will here, and so you get a something like a hyperbola here. Now there is one more trick in plotting a point which is on this line. Okay. So here, if it is exactly a line vertical to you, in top view you can see it is here, but in front view, how do you locate it? How you cannot see it here. So what you do is you imagine that if I had this particular line A2, if I had this line A2 and I rotate it here to here, then this point will come here. This point I can project it here somewhere, and wherever this will intersect, that will be the vertex. So this point will correspond to this point. So this will not be the correct figure. My hyperbola will come like this, a little shorter in length here. Alright. So that is how you project the point on line A2 on this line A2. Okay. So right now what I did is I projected the locus of point M in the front view, and I know that second locus of point M is along this line EF. So wherever this hyperbola and this line EF will intersect will give me the position of my point M and N. And once I get the position of M and N here, once I get the position of my points point M and N here. This is point M and N. I can drop a perpendicular from there. So this point M and N, to mark these here, I know that one is on the perpendicular. Second, I'll have to again draw another generator of the cone, whose endpoint I know will lie on BC. So this BC will correspond to the circumference. So this projector I'll draw here. I'll have the endpoint. So I'll have some projector A, let's say 10. So this point is 10. This point is 10. So A10 passes through the points M and N. So this is A10. I project it here. Wherever it intersects, that will be my point 10 in top view. I join it. Then I get the projection of line A10 in top view. Now I will project the points M and N. So the projection of lines M and N will intersect the line A10 somewhere here, and that is how I will get the point M here, because M will intersect this parallel line, and I will extend that projection to intersect it till N. So this will be my Mn, and finally then I will get the uh, minor axis of the ellipse. So now next thing they have told in the problem is to draw the true shape of the section, which is easier once you locate the major and minor axis of the ellipse. So now you already know that this is my Mn, this is my Mn. So you can draw a line here like this, which will be the major axis. And if you want to see the true shape of anything, what you need to do, you need to have a plane which is parallel to that plane. So you draw auxiliary plane here, x1, y1. From here, from all the construction that we have done, you already got the point B and D. You have got point M and N, which you can trace here, all the points from here to here. And those points you will trace directly on this plane. And all this ruckus, why we did it? We to get the minor axis is 40 mm. So you know that this will be 40 mm, and from this thing you will get the major axis also, and you will get the points here, um, like the this length, this length from this line you will get from the front view, and um, all these points, this distance from the center line you will have to take from the top view. So in top view you see true length of the lines which are parallel to MN. In front view you see the true length of the lines which are parallel to BD, and that is how you get the actual shape of the section. Okay, so you can try to actually draw the projections of this problem so that you will get the feel of what I was explaining right now. let us stop the meeting.